This is section 5.5, properties of logarithms. These are the topics we're going to touch on today. Property 1 are two very similar properties. Log base a of 1 equals 0, because regardless of what your base is, a to the 0 is equal to 1. And similarly, log base a of a equals 1, because a to the first equals a. Your second property is what's called the sum of logs. The sum of logs, as long as the bases are the same, log base b of m plus log base b of n equals log base b of m times n. In other words, the sum of logs is the log of the product. So if I'm adding two logs with the same base, I can combine them into a single log and multiply them. Let's look at an example where b is 2, our base is 2, m is 16, and n is 32. If I look on the left-hand side, log base b of m plus log base b of n is log base 2 of 16 plus log base 2 of 32. Log base 2 of 16 is just 4 because 16 is 2 to the 4th. Log base 2 of 32 is 5 because 32 is 2 to the 5th. And remember, logs just give you exponents. The right-hand side, log base b of m times n. Log base 2 of 16 times 32 is log base 2 of 512, which is just 9 because 512 is 2 to the 9th power. Similarly, I have what's called the difference of logs. Log base b of m minus log base b of n is equal to log base b of m over n. So the difference of logs is the log of the quotient. Again, I'll use b is 2, m is 16, and n is 32. If I look at the left-hand side, we again get log base 2 of 16 minus log base 2 of 32. Log base 2 of 16 is just 4 because 16 is 2 to the 4th. Log base 2 of 32 is 5 because 32 is 2 to the 5th. And if I look at the right-hand side, log base b of m over n is log base b of 16 over 32, which reduces to 1/2. And I know 1/2 is just 2 to the negative 1 power, so our two sides match up. I have another rule that says log base b of m to the r equals r log base b of m. In other words, if I have an exponent inside my log, I can bring the exponent out front. So again, if I use b is 2, m is 8, r is 3, we'll look at the left-hand side. Log base b of m to the r is log base b of 8 cubed. And the base b is 2, so log base 2 of 512, again 512 is 2 to the 9th. So my answer is just 9. And on the right-hand side, I have r times log base b of m, so 3 times log base 2 of 8. Log base 2 of 8 is just 3 because 8 is 2 cubed. So 3 times 3 is 9. Now let's see how we can apply these. I want to expand this. I have log of 4x to the 9th over 2y to the 5th. I want to expand the following expression. I want to simplify completely and write the answer, the final answer, without using exponents. I'm dividing inside the log. If you go back to our third property, it says if I divide, I'm really split it up and subtract. Remember, when you have a property with an equal sign, you can go left to right and right to left. So I'm going to split this up and subtract. I'm going to put my numerator first, so log of 4x to the 9th minus log of 2y to the 5th. Even though this is a constant here, 4, I can still split it up because it's multiplication. When I multiply, I add. So log of 4x to the 9th becomes log of 4 plus log of x to the 9th. I'm going to put a parentheses around here because this minus sign applies to the whole log. So minus log of 2y to the 5th is log of 2 plus log of y to the 5th. I'm going to distribute my minus signs on the right hand portion of this expression. And now I have this log of x to the 9th. I can bring the 9 out front. And a log of y to the 5th, I can bring the 5 out front. So I'm left with log of 4 plus 9 log of x minus log of 2 minus 5 log of y. I can also collapse and combine expressions as well. I want to write this expression as a single logarithm. I have 4 natural log of x minus 2 natural log of y minus 1/3 natural log of z. This becomes natural log of x to the 4th. Remember this 4 out front? I can bring it in and make it an exponent. So natural log of x to the 4th minus natural log of y squared minus the natural log of z to the 1/3. Now, if you remember natural log of z to the 1/3, 1/3 is just the cube root power. And I can combine these first two, natural log of x to the 4th minus natural log of y squared, into a single Logarithm becomes natural log of x to the fourth over y squared. And then this last one, this minus natural log of cube root of z, I can bring this into it as well and put it in the denominator. So I now have the natural log of x to the fourth over y squared cube root of z, which is what we have here. This last slide, please don't miss out on it. This is a very important one because you only have log base 10 and log base e on your calculator. And so whenever you have a different log base aside from 10 or e, you need to be able to apply this simple change of base formula. We're going to assume a does not equal 1 and b does not equal 1, and x, and they're all real numbers, then log base a of x equals log base b of x over log base b of a. This works for all bases, but typically b is either going to be base 10 or base e, so you can use natural log or common log on your calculator. So let's look at an example. Log base 3 of 14 is the same as log base 10 of 14 over log base 10 of 3. This becomes 2.4021. We can plug this back in. 3 to this power should give us 14. But again, we cannot do this original problem initially because we do not have a base 3 on our calculator. Therefore, we have to use the change of base